Flsm, we discussed about B, C yesterday. So today I'll just show the examples for class A. So requirement first question is like 10.0.0.0 slash 8, and requirement is three networks three networks with 10 lakh 10 lakh host IP address. Host IP address. So three networks with 10 lakh host IP address. So which will be the best position, bit position and block size, like we discussed yesterday. So requirement is like three networks. It should go up to three networks and 10 lakhs. You have to choose this is a class A. So class A is from this bit positions are from 8 to 15, and these are the block sizes, right, for class A. So for class B it's from 16 to 23. For class C is for 20, from 25 to 32. So now we are doing for class A. So for 10 lakh, which will be the best bit position and block size? So as I told yesterday, you guys, like if it is 10 lakh, it should be about 10 lakh, right? Like because one will go for network address and one will go for broadcast address. So here it is, we have best bit position and block size. We can choose for this thing 12, 10 lakh 48,576. So like if you're going for 13, it will become 52,000, sorry, 5 lakh 24, sorry, 5 lakh 24,000 to 288. But if you're going for 11, it's become very much more. It is it is for,
Wastage of IP address.
yeah, based on this requirement we have to choose, right? So if you are going for 12, it will be wastage. So not 12, like 11. So we have to choose 12. 12, it is nearest to whatever the requirement we are having. So best bit position is 12. 12 is the bit position, and its block size is 10 lakh 48,576. Okay. So so this is the bit position and this is the block size. So now this number is very large, where to take the requirement will be feeling difficult. So we can divide this by 10, this 10 lakh 48,576. 10 lakh 48,576, we can divide it by 256. 256 is the total IP addresses. So 0 to 255 will be 256. That is the total number of IP address. So if you are dividing this 10 lakh 48,576 divided by 256, it will be like 4,096. So this 4,096 is also a little complicated to divide it. So we can take 4096. 4096. We can divide this by 256. So if I am dividing it by 256, so if I am dividing it by 256, I'll be getting 16. So now this will be the best block size, and this will be the bit position. So now final answer is, final is 12 is the bit position and 16 is the block size. Okay, now network 1. So your requirement is 3 networks with 10 lakh host IP address. So we have a requirement is 3 networks. So we'll go for network 1. We'll go to network 1. For network 1, what will be the network 1 is 10.0.0.0.0. Whatever the question is required is there slash. So final whatever we got. So now we are converting this into the subnetting. We are using this table converting. So its CIDR will be 12. It will be 12. Again, next, this is the network address. That will become network address. Again, next 10.0.0.1. This will be the first host IP address. Again, next network, it will become 10.0.0.2. This will be the second host IP address. This will be the second host IP address. So what is the broadcast network for this, for network 1? Broadcast will be 10.15.255.255. So this will be the broadcast address. This is the broadcast address. So what will be the
Oh,
last?
why it's 15 there?
Oh, see, like requirement is 3 networks, right? Requirement is 3 networks with 10 lakh host IP address. So here you can see 16.
Yeah,
16,
okay.
right? Like its block size is 16. So 16 will be the next network.
Okay, okay, getting it.
Yeah, 15 will be the broadcast address. Okay, again here I'm going to minus 1. 10.14.255.255. So this will be the,
Last IP address.
yeah, this will be the last host IP address. So what will be the network 2? Anybody? What will be the network 2? Can somebody tell what will be the network 2? So next coming to
10,
network, huh?
10.16.0.0.
Okay, this is the network 2. Network 2 will be 10.0 dot, sorry,
16.
10.16, right? 10.16, 16.0.0. slash 12. This will be the network side. This is the network address. Again, what will be the broadcast address for this? Srija, you can answer me because you have done, right?
Yeah, 10.16.255 dot
Broadcast address, broadcast.
10 dot 16 plus 12, right?
Yeah,
16 plus 16, 32, 30,
yeah.
31.
So 32 will be the next network, right?
Yeah,
So
10
here,
dot 31.
yeah, 31 dot 255 dot 255. So this will be the broadcast address. This will be the broadcast address. Okay. So now you guys are familiar with first host IP address and last host IP address. I'm not going to write for everything. I have showed the first example. So next, coming to network 3. Coming to network 3. So network 3, what is the network address? 10 dot 32. 32 dot 0 dot 0 slash 12. This will be the network address. This will be the network address. So what is the broadcast address?
10 dot 47.
47, right? 47 dot 255 dot 255. So this will be the broadcast address. Okay. So here requirement is 3 networks with 10 lakh host IP address. So we chose which is the best for this bit position and block size. And if it is the number is greater, we are just going to divide by 256 and we are going to simplify it, and we are going to do this all these things: network 1, network 2, network 3. So 0 to, yeah, 0 to this 15 will be the first network. Again 16 to 31, this will be the second network. Again 32 to 47 will be the third network. Going to 48, that will become the network 4. So what is the subnet mask for class A? Class A subnet mask. Class A subnet mask is 255.0.0.0. Class A subnet mask. So coming here we have 16, sorry 12. So require like our CIDR is 12 here coming to this. But the slash is we are not considering, we are considering slash 12. So this 255 is already constant. We are not going to change this number. So it is having already 8 bits. This one is already having, this one is already having 8 bits. So requirement is 12, right? Yeah, this is 12. So now we want still how many values? 9, we want 9, 10, 11 and 12. So 9, 10, 11, 12. So still we want 8, 16, 32. We want to get some more 4 values, right? The for class A, like normal like normal class A, it is the subnet mask will be 255.0.0.0. But when it's coming to subnetting part, we have to look subnet mask for slash 12. So here you can consider, as I told, you have to consider first 8 bits. So this 1, 2, 4, 8, 16, 32, 64, 128. You have to consider first 8 bits. So now requirement is 1, 2, 3, 4. You have to add first 128, 64, 32, 16. What will be the answer? 128. So for 9, we are going to take as 128. Again for 10, it will be 64.
64.
Yeah, 64. Again next 32, 32, then 16, then 60. So what is the answer for this? 1, 2, 3, 4. 4 requirements we have taken. So what is the like addition and just tell me no. What is the answer we are getting?
240.
240. So for this, for 10.0.0.0 slash 12, subnet mask will be 255 dot 240, right? 240.0.0. This will be the subnet mask for this requirement. Did you guys understood this concept? Okay, next I'll be moving to class B. Yesterday I did class C. Now next problem I'll be doing for class B. So Flsm class B. So our question is like 150.10.0.0 slash 16 and requirement 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 is 2000 2000 PC into two networks. So our requirement is 2000 and we should get two networks. So which will be the best block size and bit position? See if you guys are getting just
2048.
yeah.
21.
So I like Shrija, she shared all her whatever homework problems she did best. Like from others, I didn't get any response. If you guys are getting, just tell or else I can explain it again because it's an online class. I don't know how you are understanding, but some people who is understanding they are just sharing their notes. Like ma'am, we have done. Just check it out. So like requirement is for what is which is the best bit portion and block size
21.
21
2048.
and 2048, right? So we can divide this one 2048 divide by 256, sorry. So what will be the answer if you're dividing it?
8.
8, right? Okay, 8. So now its bit position is 21 and its block size is 8. Final value, whatever we got now. This is the final. So now coming to network 1. Network 1 is 150.10.0.0 slash 21. This is the network address. This will be the network address. And what will be the broadcast address for this one? Srija, what is the broadcast address?
150.17.255.255.
150 dot, I didn't get you.
17.
No, see in network, like in class, like this is class B, right? So
Yeah.
network side, we have two network side. I have told in the beginning class only. Like network side is two. We have for class B, we have two network side. So that is always constant. We cannot change. But in case of class A, when I was doing, I was changing here also. You guys observed or no, I don't know. So we have only one network side, so we will start configuring from this place, from here. But in case of class B, these both are constant. In case of class C, all these three are constant. We are making changes only in the host side. So here 150.10 is
10.
constant
Okay.
because that is the
10.
network side. So what will be the answer now?
150.10.17.255.
7, right?
7. Yes, sorry.
Yeah,
7.
7.255. So this will be the broadcast address.
Why it's 7 there? I couldn't understand.
Yeah, I will just tell you. This is the broadcast address. Like Vinuta, right? You're talking?
No, Pavitra.
Okay, Pavitra. Just look here. Like I has, as I told, in network side we have two constant, like 150 and 10. So we are not making. We have two network side and two host side. Till that part you're clear, right? It's constant,
Yeah,
not
yes.
making any changes. So how do we get change? Like yeah, 7. See, network 1 is 10 dot, sorry, 150.10.0.0 slash 21. So network 2, here we have 8. This 8 will become the network 2. Okay. So before network, like before 8 we have 7. So that 7 will be the broadcast address for network 1.
Okay,
Okay.
getting it. Okay, thank you.
Yeah. So that is network 1. So coming to network 2 now. Coming to network 2. In network 2, 150.10.8 dot 0 slash 21. So this is the network address for net, sorry, yeah, network address for network 2. This is the network address. Again, 150.10.15.0 slash 21. This will be the broadcast address. This will be the broadcast
15.255.
address. Okay. 15.255. So this will be the broadcast address. So our requirement is only two networks. If it was three networks or four networks, you keep adding. Now 8. We got 8. 8 plus 8 will be 16. So that 16 will become the third network.
But
Yeah, again, if they're asking for four network, again 16 plus 8. It keeps adding how many networks, what will be the requirements, you have to go according to that. Okay, so now for this, for what is the class B subnet mask? Class B subnet mask is 255 dot
255.255.0.
255 dot 0 dot 0, right? So here our requirement is 21, right? So this already we are 8 is reserved, 8 is reserved already, right? 8 plus 8 is 16. Already we have 16 bits here. So now 21. So 17, 18, 19, 20, 21. Still 5 bits is pending for this requirement. So what will be the subnet mask for this slash 21?
248.
Yeah, 248, right answer. So subnet mask subnet mask will be 255 dot 255 dot 248 dot 0. This will be the subnet mask for this requirement. So anybody is having doubts with this concept? So next,
Ma'am, I did not understand last step.
which this subnet mask.
Subnet mask. Yeah.
Okay, fine. See, like normal subnet mask, like normal classes we did class A, B, C. The normal subnet mask for that for class B is 255 dot 255 dot 0 dot 0. Done. So 8 plus 8. So this value will have is it has 8 bits, and this has 8 bits. This has 8 bits. This value will be 8 bits. That in the beginning classes I told you guys. IPv4 address is a 32 bits. So it has 4 section, and each section will have 8 bits. Okay. Now this 16 is already reserved. We cannot make any changes because it's already 255, 255. So here the requirement is 21, right? You can
Yeah.
see this
Yeah.
yeah, bit position is 21. So I want for this requirement 21 subnet mask. So how we are going to get, you have to go look at this what is this block, this subnetting table, this block size and bit position. So you have to look at first 8 bits. If you want to calculate subnet mask in this like subnetting, you have to go to first 8 bits. So requirement is 21. So 16 is already there. 8 plus 8, 16 is there. Here slash 21. So now requirement is 17, 18, 19, 20, 21. Requirement is for 5 bits. So you will go with first 8 bits. In this first 8 bits, you will go from 256, 256, 128, 64, 32, then 5. So you are adding this first 5 bits. So you will get this value. If it is slash 22, you will go with 6 bits. All this till 6 bits. If it is slash 23, again you keep adding. You guys got or no?
No, ma'am. I didn't understand that. Why you are taking 24 and 25? That's-
I don't know how to explain in online class because this is my first online class. Because I take only offline. Okay, I'll try to explain. Mm, okay, as I told, in normal subnet mask, you know class B, right?
Yeah.
Class B is 255.255.0. So class B normal is 255.255.0.0. Normal, this is the normal subnet mask for class B. But now we are doing this subnetting to avoid the wastage of IP addresses, right? So now I want subnet mask for this requirement slash 21. So can you make changes in network side? In the beginning only I told you guys.
No, these two are
So
constant.
255, 255, you cannot make any changes. Okay. But you to add the subnet mask, so you just keep in mind like this. This is having 8 bits, right? Now,
Yeah.
yeah, this is having 8, and this is having how many bits?
8.
8. So total how many now?
16.
16. Okay. Now here we are having already 16. 16 is done. So what is the requirement here for subnet CIDR?
21.
21. So how many is remaining still?
21 minus 16. 5.
5 is remaining. Now
Yeah.
I want 5. 5 bits. 5 bits are remaining to me. So 5 bits. So how you are going to get this 5 bits means you have to go to this subnetting table. So you have to look at first 8 bits.
This is class B, right?
Yeah, this is
So
class
you.
B. So
Mm.
you're not looking at class A or B or C for subnet mask.
Okay, okay.
Okay, so you have to look at first 8 bits. You're going to add,
Oh,
like requirement is 5 bits. So 128, 64, 32, 16, 8. You add this and you can write 255.255.248.0. If requirement
okay.
is 6 bits, you will go up to 6. 7 bits, you'll go up to 7. If it is 8, you'll go up to 8. If you are getting
Okay,
9,
starting from 128.
yeah, it is going to start from 128.
Okay. Okay, ma'am.
Okay, you have to consider this first 8 bits.
Okay.
Okay, then you're going to get the subnet mask. That's it.
Okay.
So any others is having any doubt in this FLSM? If you have no doubts, I can move to VLSM.
Yeah, we are clear, no doubts.
I am busy, full busy. Busy. I'm sorry. I didn't teach you yesterday. BTC. Is it? Okay. When you're free. Okay. Yeah. He will not talk. He will play silent. Hmm. Okay, fine. Okay, okay, fine. Okay, now we'll be starting VLSM. So VLSM will go from class C because VLSM in class C.
Ma'am, a small doubt, ma'am.
Yeah,
Ma'am, you're pasting this block size and bit positions, no?
yeah.
So when it is 8, how we know that it is 16, the 16 like something? How is it like we have to mark up, or is there any other ways of finding 8 is equal to this number?
See, it's not. Why should you want a mug up? Why, like,
Mm.
you have to just know how this is working, subnetting table. So, no need of mugging. Like, you can calculate, right? 1 into 2 is 2. 2 into 2 is
Mm.
4.
4.
4 into 2 is 8. 8 into 2 is
Okay.
16. 16 into 2
Okay.
is 32. 32 into 2,
Yes. Mm.
64.
64.
64 into 2
Yes.
is 128. 128 into 2, 256. So
Yes.
256 it is class C. Again into 2,
Okay.
512 into 2. Keep on going. So you can go up to like what is that, 1 crore 67 lakh 77,216, because you know this, at least this value, right? Class A we have
Okay.
1 crore of IP address, like 67,077. I now you're clear, right? Whatever I told.
Yeah, I understood. But if you are working in a real time, in case if it is like slash 15 is given,
Yeah.
then corresponding bit position, I don't have to calculate the time. No, so it's like is there any easy way of finding
See, once
15
you
is
get into
equal to?
real time and all, it's like you're using Google for everything.
Yes.
You
uh,
cannot sit and calculate and waste time. Your
okay.
troubleshooters, like you are going to troubleshoot, you should be very quick. You cannot
Mm.
keep calculating all these things and doing. Just go type
Okay.
Google, just try to crack your interviews, get into companies, then everything is done easily. Like if we
Okay.
don't know anything, we have to Google. Everything is going to
Mm-mm.
tell step by step, right?
Okay.
Yeah,
Okay. Thank you.
yeah. So next, VLSM. VLSM means variable length subnet mask. So FLSM we studied, it was fixed length. Like I was taking same CIDR range for everything. But in case of VLSM, we will the variable like length like it's going to vary with its CIDR ranges. Like I'll just take the example like 192.168.0.0/24. Okay, this is our question and our requirement. Our requirement is 16 PC, 16 PC into two networks, 16 PC into two networks. Again, next requirement is 10 PC into two networks, into two networks. Again, 4 PC into three networks. So first, what is the best bit position and block size for 16 PC into two networks? For 16 PC, which is the best block size and bit position?
32 block size, 27 bit position.
Okay, so 32. So block sizes, block sizes 32, and its bit position, its bit position, its bit position is 27, right? Okay. Next, coming to 10 PCs into two networks. For 10 PC, which is the best block size and bit position?
16 block size, 28 bit position.
So 16 block size and 28 is bit position. Again, coming to 4 PC, 4 PC, which is the best block size and best bit position?
8 block size, 29 bit position.
Yeah, why should I not go for 30? We have 4, no? Hmm? We are already having 4. Why should I go to 29 and 8?
Because we need more.
Network address and broadcast address.
Yeah, yeah, exactly. So, like once I do -2, it will become 2. Then requirement will be only 2. But your requirement is 4 PCs. So, we are going for 8. 8, 29 and 8. So, block size is 8 and bit position bit position is 29. Okay, so like previously we studied FLSM, it was a fixed length, but here variable length subnet mask, it is going to vary with its subnet mask. So network 1 coming to network 1. So in network 1, it will be 192.168.0.0/27. So as I told, this is the bit position 27. This is the network side. That will be the network address. That is the network address. Again, 192.168.0.31. This will be the broadcast address. This will be the broadcast address. Okay. So again, your requirement is 16 busy into two networks. So next, I'm going to network 2. Network 2. In network 2, it will be 192.168.0.32 slash 27 and its broadcast address will be 192.168.0. So 32 plus 32 will be 64. So 64 will become the next network. So 61. Sorry,
3.
63. 63. This will be the broadcast address. Will be the broadcast address. So network 1, network 2 is done for this one. So for next 10 PC into 2 networks. Next coming to network 3. Coming to network 3. Network 3 it will be 192.168.0.64 slash, what will be the CIDR for this?
28.
28. Again, what is the broadcast address? 192.160 168.0 dot, what will be the broadcast address?
79.
127.
79.
So like 127, how did you get 127?
Sorry, I thought like next will be 128,
Mm.
and it will be next network. So 127 will be the last.
No. I think you got it. So 0 to 32. Right. Again 32 plus 16.
Okay, that is what I calculated wrongly.
Okay. Don't get confused. Now 192.168.0.79. 79. This is the broadcast address. This is network 3. See 0 to 30, 31. This is the network 1. Again, network 2 is 32. So your requirement is 2 networks. So 0 to 32. Again 32 plus 32. 32 plus 32 is 64. So network 1 and network 2 is done. Okay, now coming to network 3. 64, we got 192.168.0.64. Again, next coming to network 4. Coming to network 4. What is the network 4?
192.168.0.80.
0.80, right? 0.80. So this will be the network address. This is the network address. Again, broadcast address will be 192.168.0.95.
Right.
Again, I'll explain if you guys are not understanding. Your network 5. Network 5 will be 192.168.0.96 slash 29. That is the network address. Again, broadcast address will be 192.168.0.103. That will be the broadcast address. Then coming to network 6. Then coming to network 6. Network 6 will be 192.168.0.104 slash 29, and its broadcast will be 192.168.0.111. That will be the broadcast address. Then coming to network 7. Network 7. Network 7 will be 192.168.0.112. That will be the network address. Again, its broadcast address will be 192.168.0.119. So this will be the broadcast address. So we how your requirement is 2, 4, 5, 6, 7, 8. No, 3, 4, 5, 6, 7. Right? Yeah, 7. We have got 7 networks. So I'll tell you again. See, network 1. Network 1 is 192.168.0.0. So whatever the requirement we got for 16 piece into 2 networks, here CIDR value is 27. So we have to get 2 times 27 because 2 times network address. So sorry, we have 2 networks for requirement 16. So 27, 27 2 times. So again 10 PC into 2 networks. Your requirement is like 2 networks. So your bit position is 28. Again we are changing your bit position to 28 and 28 here. Network 4, this should be 28. This should be slash 28. This should be slash 28. Again, your requirement is 4 PC into 3 networks. So we have to get bit position 29 3 times. 29, 29, again here 29. Here we have to get 29 slash 29. So network 1 is 192.168.0.0 slash 27. Again, this 02, it will go up to 32. This 32 will become the next network. So before network 0.31 will be the broadcast address. So 02, this is the one network. Again 32 plus 32. 32 plus 32 is 64. 64 will be the network 3 and broadcast address will be 63. So for this requirement, 2 networks is done. Again, coming to next requirement, its bit position is 28. And now we have to add 64 plus 16. This 16. 64 plus 16 is 80. So you can just type 64 plus 18 is, yeah, 64 plus 16 will become 80. So this for this network 3 broadcast address will be 192 168.0.79. That will be the broadcast address. Again, 80 plus 16. 80 plus 16 will be 96, because here 10 PC into 2 networks. We have to add 2 times. So it will be 96. Again, 96 plus 8, because 2 networks is done. Again, we are going to next requirement. 4PC, block size is 8, bit position is 29. Again, 192.168.0.96 plus 8 will be 104. And for this network 5, broadcast address will be 192.168.0.103. Again, 104 plus 8 will be 112. And for this broadcast address will be 119. And for this network 6 will be 111. This will be the broadcast address. So we have to go for subnet mask. Subnet mask. What will be the subnet mask for this requirement? 192.168.0.0/27/28/29. We have now 3 requirements. So all the 3 will have different subnet mask. So what is the subnet mask? Please tell me. For this slash 27, what is the subnet mask? So coming to network 1 and network 2. For slash 27, what is the subnet mask? And next slash 28, what is the subnet mask? And slash 29, what is the subnet mask? Srija, tell me.
For subnet mask for 27 is 255.255.255.224.
Okay, correct. 225.225.224. Next slash 28.
24, 28, 255.258.240.
240. Okay, correct. 255 dot
Um,
255 dot 240. Again
40,
slash 29
248, right?
to
48.
48, correct. 255 dot 255 dot 255 dot 248. So this is the subnet mask for all these 3 requirements. So I will be sharing some homework problems also on the group. You guys try out for today. If you guys are not getting, just ping me, or we'll discuss in tomorrow's class. And tomorrow we'll be doing Vlsm class B and A. For tomorrow, subnetting is done. Then we'll go for routers interaction. Okay, any doubts, anyone?
Ma'am, please upload the recorded version, ma'am.
Yeah, I have recorded and I'll be sharing. See, like
Okay.
if I tell I'll be recording the classes, all are messaging me, please share me the recordings, please share.